Hello and welcome back to another episode of the Reliability Gang podcast, and it is part 2 time. We have a special guest again.
Yeah, well...
Hello, Mark. How are we keeping?
Yeah, thanks very much. And yeah, we're back in the studio, so thanks very much for the invite, Will.
Honestly, it's been probably the most exciting week again. I honestly get giddy when you come down because we're just doing all sorts of tests. You know, we're jumping into electrical tests, and this time it's not just been Mca, it's been motor current signature analysis as well.
Yep.
So we've got like machines when they're off, we're doing tests there, we're understanding what that means with the data, and then we're looking at machines when they're running again. Mm-hmm. And we've just got this whole new wave of information this week, and my head is honestly just...
Yeah, and being able to do the tests both running and offline, it just tells you so much more about what's happening in your motor, and it uncovers some pretty good energy efficiency gains. So,
but this is the thing for me as well, because, you know, at Maintain Reliability, everyone knows we bang on about it all the time. Strategy, get the data, understand what it means. And it is so important. And I think we all do know the importance of it. But again, I think some of the things that we're going to talk about within this podcast with words like how much data you've taken and how many tests that you've done, and really basing lots of facts. And one thing in reliability that's so important, and you'll know as well, if you haven't got the information, it's difficult to do the statistical data that tells you what the future is going to be and how you're going to be able to implement it. And it's the same with like customer CMMS systems. If they don't have that data, how can they extrapolate it and be able to make use of the value of it?
Yeah.
But I mean, that's the thing, Mark, that we live in a world today where there's lots of data sources coming in, but sometimes it's not aimed at the right purpose or value. And this is the problem. We need data, but we need meaningful data, don't we?
Yeah, and data that you can actually trust.
Yeah.
Because it's the quality of the data.
Yeah.
Yeah.
It is, and that's the thing with what we've been doing this week, and it's just been such fun. We've had a ball. What we've done, obviously, we've invested in the All-Test Pro, incredible piece of equipment, and also the Empower as well.
Yeah.
So obviously Mark's used these devices and had so much data again, and we're going to get into kind of a little bit of a case study that Mark's done with the All-Test Pro, which is incredible. But learning both sides and the importance of why electrical condition monitoring and condition-based maintenance is important, but not even just to do it as a CM function or CBM function, it's to do it to improve the reliability of your plant and all the rest of it as well.
Yeah,
you know?
Yeah. I mean, I've been testing motors since '97.
Wow, a long time.
And
I was 10 when you started.
Yeah, but I got a bit of grey hair. Yeah, so the offline testing with motor circuit analysis has been around for quite a long time, and I've only really started with Empower, which is the motor current signature analysis since beginning of this year. And that technology's been around for quite some time, but it's not until it's been made very usable.
Yeah, I agree.
And
you learned about like motor current signature analysis in like courses and stuff, but it's always like a tiny little section on it, and that was it, and you didn't hear anything else, did you?
Going back decades ago, I had a current clamp on a VA analyzer, and
that was basically Mcsa.
And I had a go at doing that current signature analysis, and it's hard work to get it to get meaningful data out of it. So it wasn't until MotorDoc came out with Empower earlier this year that has a onboard AI model for doing the analysis for motor current signature analysis.
And I think this is the evolution, because what I've seen in terms of the software, like, I'm quite hard to impress, to be honest, because I've been around the block. But I'll be honest, with the way that's laid out, I mean, shout out to Howard Penrose, what an incredible thing he's created here. Mm-hmm. But I think what's more impressive is, like you said, we've got a signal there through the electrical signal, but how are we extrapolating it to have valuable information to what we need? So, it's great to have all the information on defects, but it's also, what's really impressive is to understand the energy efficiency side of the motor and how quickly it can identify that.
Yeah.
Is just phenomenal. And I think this is a game changer, if I'm being honest.
If you've got a pretty good laptop, you can take the data and then you hit the auto analyze and you get a instant findings within probably 30 seconds.
That's just incredible.
Yeah, and it's a game changer.
But again, I think this is the thing that people also need to understand. In order for it to do that, how much research, how much development, how much knowledge goes into a model like that. This is where you have to take your hats off to someone like Howard in terms of putting basically this whole life findings into this one kind of product, really, isn't it?
Yeah, and it's developing very quickly. I mean, the difference really is that it has an incredibly high sample rate.
Yeah.
44 kilohertz.
It's just,
And during that 120 second data capture, it's at about 5.2 million lines of resolution.
It's ridiculous. So to be able to have both of them, like all of my vibration analysis followers and people that watch that can now have probably their jaws on the floor because they probably understand how quick they're sampling at in terms of vibration spectra. But to be able to have that much resolution with that frequency, range is just it's unfathomable. Yeah,
and the issue is that the best VA analyzers, 16,000 lines of resolution or whatever.
You're looking at 16 to 32, aren't you?
It's
which is still very high res, by the way. You can still find it.
But the issue is that mPower is at least 10 times that, and you need that resolution to be able to see some of the electrical faults that you see in electric motors.
Yeah, and that's the trouble, because obviously for a long time we've seen electrical frequencies in spectra and vibration, but it hasn't had the ability to be able to do what Mcsa is doing right now, to be able to really look even deeper into the causes of that electrical kind of response. Because a lot of the time when it comes to electrical, you'll ask any vibration analyst, they can identify it is, but that's about as far as it goes.
That's right.
It's like you're finding, you might be able to see it's the rotor, or you might be able to see some inverter frequencies, but what actually is causing it, and more importantly, is it damaging or not?
Yeah, and also
sometimes it is, sometimes it's not.
Yeah, like I was with Will, on a client site yesterday, and a few days before that, and I mean we put the mPower on at the board at the bottom of the drive, just around a single clamp of single phase, and I said, it's got a bit of cage loss there, and your lubrication looks like it's been decayed. So it's not just electrical issues.
Of course.
We can see all the bearing issues. If we put the fan bearings in, we could do exactly the same.
Yeah, and that's blown my head a little bit. I need to do, and again, I said to Mark, I need to do my own tests. I need to do and boy, you're gonna see me now. I'll tell you now. How much data, and I told this story to Mark, actually. He laughed as well, because when I first started the business, we used to use SKF, and I bought, it was Proof Technic actually, the first, because at the time it was the only thing I could afford really, whatever, and I just remember, because it was new, I was like, right, I need to test. And I was on site probably till like 7 o'clock in the evenings. And the missus like, when you coming home, what are you doing? I'm like, I'm just taking data. I'm messing with filters. Yeah. And I got that feeling back again with this. Yeah. Do you know what I mean? Like, it's got me really, like, don't get me wrong, you know me, I'm passionate about what I do. I love what I do. But I've never felt this excited for something within the business for a long time.
I mean, I think it is very much a game changer.
I think so. I think that's why I'm excited as well, to be fair.
And it's an extra sort of string in the bow. It's not going to take over from VA.
No, of course, but it's a great assessment.
But it's very much going to complement and give you a different angle. And I always say to clients, if you need to confirm a defect with at least a couple of technologies. If you're relying on one technology, you can often make a mistake.
100%. And I think that's also us at Maintain. We haven't just done vibration. We do ultrasound, we do, all analysis and all these, even when you get an ore sample on the gearbox and you put that with the vibration, just how much clearer is the picture in terms of what decision the customer makes. And we've got to also make sure that we get as much data as possible to make the best informed decision. Because maintenance at times, Mark, it's not easy. You've got limited downtime, got limited availability, might get a bit of a shutdown window. You want to be really sure about what things you're changing before you do them actions. And I think this as well electrically allows us to be able to find a lot of root causes of problems that people are completely unaware of because they're hidden. The hidden electrical truths, isn't it? About some of the things that we're finding. And that kind of brings us on to our next kind of conversation, which I'm really quite excited about, because when we spoke about data, we spoke about how important it is to capture it and meaningful information. And within the world we live in now with AI and the way it can kind of crunch statistical numbers, we are in a really interesting time because, me and Willa spoke about kind of the involvement of AI and the involvement of how it kind of makes our life easier as maintenance professionals. But we said one of the main things you need is really good, valuable, reliable data. But you also need a lot of it. You can't model off small amounts of things. So obviously the capturing of information is really important. So Mark's been telling me about the 750 motors that he's been testing. How much did I get that right?
Well, we use the all test to take offline data.
Yeah, this is the MCA.
And it holds 500 tests. It allows me at any one time, and then we download into software and we do obviously our analysis. But the beauty of that is I can export it, and this year so far I've probably done, well, and counting the ones this week, probably about 770, something like that, motors. But I exported 755 motors into a spreadsheet. I've then fed that data into DeepSeek AI, and I've asked it to do what we call cluster analysis and correlations between all the different tests that the all tests do. And
incredible, yeah. The results were like quite.
And I've taken a little bit of a few notes here.
If people want to read this, I've linked the actual article below in the description, and obviously it's a little case study blog. Basically how the tests were done in every bit more detail. But make sure you check it out as reading a bit more detail as well.
It's a blog article on my website.
We'll link it below as well, so have a little look at that.
So the all test does a couple of winding tests, so you can actually predict degradation of motor winding issues. And those tests we correlated with impedance and balance. And an impedance and balance is effectively, the resistance to current flow in each of the three phases. So that correlation, if people know a little bit about stats, an R.82, which is the correlation between the winding defects and impedance imbalance, that's really strong.
Yeah, and that's interesting as well, because it's quite important as well. The thing is, when we test for a winding, there's lots of tests we do, and there's lots of different failure modes for a winding, okay? This is also really important, guys, where we just don't rely on insulation resistance, because it's telling us this much of the story, do you know what I mean, of what we're doing. So when Mark's going through the statistics, this is why it's important to be able to put a couple of them together and see what the relationship is with percentages of motors that are going through the same problems.
So we've taken a large population of motors, and what we're finding is that under normal conditions, good quality motor, that impedance and balance on average is less than 5%.
Yeah, so we've got a bit of an alarm kind of status level now in terms of real-time data. And this is also really honourable, because we can't just rely on manufacturers' alarm levels.
That's right.
Or people. We have to do our own data. And I've done the same with vibration, but you can only do that when you've modelled a lot of it.
Yeah.
Because
Yeah.
you can't have the confidence to change things until
Yeah.
you've done that.
So this data, being a large population, it absolutely matches the alarm levels that are preset in the instrument.
Yeah.
So I've actually used real life data to prove
confirm the alarm's okay.
to prove that the instrument's about right.
Yeah, because that's it's the same. Like even in vibration, like remember we've only got ISOs for velocity.
Yep.
Like for acceleration and envelope acceleration, different devices will calculate that overall value differently. So we've got to be able to use our own information on what is good and what is bad, and then make them alarm levels from that.
Yeah. So the issue is that not many motors are down under 5%, and when that cluster analysis, there was a thing called coupling initiation, which is the stats are telling me that there's a small correlation there, and what that means is that in early winding defects happen between 5 and 8% impedance imbalance.
Okay, cool.
But once the impedance imbalance is much higher, and I'm talking like the next level was 8 to 15%, that's what they call accelerated degradation.
So kind of when it's a bit like when you get into that area, the wear rate will increase
dramatically.
Yeah.
And then there's a critical coupling, and that's above 15%.
So anything above 15. So when you're talking 15, you're talking, right, this could potentially fail.
Well, it's the actual impedance imbalance is not the failure mode, but it's so tightly correlated to the actual winding defect.
The winding failure, okay, cool.
Because, when you think it through, an impedance imbalance means it's like a wheel out of balance on a car.
Yeah.
It's going to stress the tyre wear, the suspension, and it's going to use more energy.
Okay,
that's exactly what's happening in the motor.
So it's kind of like the cause for the winding defects. So so we can have poor impedance balance from the get-go, can't we? From manufacturer, can't we?
And it can be related to a number of variables, and that is the rotor quality. Can be air gap, and it also can be a defect in the winding. So there's multiple
failure modes.
Causes. But overall, if you correlate impedance imbalance with winding defects...
It's such an important one.
And I think you can't argue.
You can't. It's in your data.
An R.82 is an incredibly strong correlation.
It is very strong,
So
very related in that data.
We were with one of Will's clients over the last few days, and they have got a few new motors.
So let me explain the story a bit of context. Because I can't name any names or anything, but it's quite ironic, this story. And this is what we do at Reliability Gang. We don't there's so many stories behind plants, and it's so interesting because they're so, and it's also so valid to why we do testing and what we do. It's a confirmation of why we do what we do. But customer that was at this week, they've got something called like a carbon fund. So the idea of the carbon fund is like a bit of a rebate. When you spend with the supplier, they have a rebate to get put back to spend back for energy efficiencies, which I actually think is really good. The premise of it is a great idea, right? So what was done, they had two main fans that they run, quite big fans, very critical assets. And they also thought, well, do you know what? If we can get a new motor as well, great, we extend the life of it and all the rest of it.
And it's had some inverter issues with the bearings.
Yes, it has. They know that as well because we've found the problems using VA, and we've also tested and we've confirmed that there's 100% issues coming from the inverter and there's EDM damage happening. So obviously when it was done, these are supposed to be IEE4 motors. Okay, so
they were the replacements.
They were the replacements. That was the idea. The new IEE4s go in, they're more efficient, therefore saving more money, justifying the carbon fund. So kind of done this, and do you know what? We was there this week, and we was doing some tests with the All Test Pro. Right? Teaching me how to use, because I've got my own now, and I'm looking all snazzy with my bag, but still need to learn how to use it and get some tests. So it was like, well, perfect opportunity to do a bit of training. We've got two new motors. Can we test these? Perfect, because they're out easy. So when we test them, Mark, what did we find?
Well, the first one, it had about 15% impedance imbalance.
Go into Mike's list. We're going to look at that.
So that's right on that critical coupling.
It's on the critical mark already.
Okay.
Yeah, crazy.
But then the second one we tested was 18%, right? And it's already got an early winding defect in
What
it.
the hell? So the context of this, these are brand new
They were still
motors.
they were still in the crate.
They're in the cellophane, basically. And this is alarming. And this, I was shocked, personally. To be honest, we only tested them for training. So the fact we found defects at the rate they were, and, you know, obviously spoke to the customer and obviously not happy with it, and they shouldn't be. But this also identifies why acceptance testing is so important. And we don't, in the industry, we don't do this. We just don't do it, and we should do it, you know. And, you know, Mark's on a mission as well to be able to create some new standards with customers, because it's not difficult to create a good standard
No.
when we understand what we need to make sure is actually a good quality motor, you know, and more importantly, obviously a lot of these checks probably from manufacturer probably are not being done, or even worse, they are being done and sent out anyway. We've got to be able to say, well, what is the testing criteria? And we've got to understand what it means to have a good quality mower, because there's lots of different things that can go wrong. It's not just a simple asset, is it? You know?
Yeah, so to give you a little bit of a background, I actually went to a motor manufacturer and did an acceptance test for a client. We'd written into the purchase order the requirements, and I went there and we got a motor that was less than 6% impedance
balance, yeah.
I mean, there was a little bit of rotor showing there, but it was generally
good.
really, really good motor. So that's down, you know, in that normal, acceptable range.
Yeah.
But the two motors that we tested this week
Completely out.
are way off. I mean, 18%.
They're in critical alarm, aren't they? Really, in terms of what that impedance balance means, and that also means the fact they're supposed to be efficient. They're not going to run efficiently because the magnetic field basically there is imbalanced. So that's going to cause a lot of different higher current scenarios and cause havoc for the motor. So we don't want them defects into our plant. We want to eliminate that. What we need to make sure is at brand new, when we're spending that type of money, that what that asset is going to be as good as it can be before it starts running.
Yeah.
And the thing is as well, it's very difficult to be able to test for that. If you're only doing insulation resistance tests, you're not doing enough to understand the quality of that winding.
Yep.
This is why the All Test Pro is really important for our strategy as well, because it's also understanding all the other failure modes that we're not testing for that are hidden, and they then become problems later on. You know.
And I've got to add also is in the IEEE standard, it states that any break in magnetic symmetry in a motor, in other words, impedance imbalance, rotor defect, or whatever it is, this creates shaft current.
And that adds another layer.
And then you end up with a circulating current, and this is going to destroy your bearings.
As well,
So when you buy a motor which has these problems, you're never ever going to completely fix the problem.
No, but not even that. You're detrimenting your reliability.
Yeah.
And generally, for your most critical assets, then you're going to maybe damage the bearing. Then you're going to damage, and the knock-on effect from it is, and that's the thing with electrical that people don't understand, it's the knock-on effect damage that the further it goes down the line, the more damaging and expensive it is to a business. So if we can capture that element at the get-go, and we can avoid these things coming into our plant by simply writing out a standard that we have deemed acceptable for these motors to come in to be able to operate. And, you know, when we're spending 40 grand on a motor, we expect it to be able to live a long life, and we expect it to be able to do its service for the critical asset that it is. So why are we not writing these standards? And we all have the right to write a standard of our purchasing terms. Every business does. You just need to know the metrics that mean it is a good mower. Does that make sense?
And people got to realise that there's quite a high variability in impedance imbalance.
Yeah, 100%.
And the problem is it's not in any IEC standard, but the thing is it's so highly correlated to winding defects.
Well, we've seen it in the data. We've got proof of this. So this is also another really important metric. And, you know, I understand it can be difficult to get your head around in terms of it not actually being a failure mode, more of a cause of failure. But we have to look at the data that correlates them winding failures, that a high percentage of them happen because of the impedance imbalances that take place. And there's the data that we have to extrapolate and have a look at the article to see and understand what it means, because it is probably one of the tests that is going to let you know whether your motor is fit for service to begin with. You know what I mean? And, you know, it's not, again, we could find motors with faults already, but we need to have a look at the main causer of them faults and see how that motor has been manufactured to avoid that from happening. That needs to happen at the manufacturing process. Once that's happened, you can't go back. You can't improve that number. The motor is the motor's impedance imbalance, you know.
And I mean, this is backed by like thousands and thousands of tests. I mean, I honestly, I think for myself, 3-5 reliability, we're the only people out there doing like hundreds and hundreds of tests
on these motors
every year, and then using that data to actually make decisions.
We're going to share data, so you know, I'm going to now test a load of this stuff, and this is going to go into Mark's database to refine these models. And you know, that's what it's about now, isn't it? It's about trying to be able to use this information to keep learning. And you know, we've got other test results as well, and we've got other test equipment. So what I'm going to do now is also test between the test equipment and see what correlations we can get, because I think that's very important to know what we're missing here.
The issue there is that, you know, the data doesn't lie. And if you don't have data, you've only got an opinion.
You just got assumption. And we can't assume when we're talking about such critical assets. You know, we've got to be able to be informed. And again, it goes back to the saying, we're drowning information because we get some information's crap. We need the right information based on what we're looking for as failure mode. But then we need to use that information to be able to make better decisions. But we also have to back up the data we've taken to verify decision making.
That's right.
So when you loop them three things together, what you get is value decisions based off real information. And where we live right now in this industry, we have too much information that's poor. We don't have enough data that is valuable.
That's right.
And that's what we got to do. We've got to make sure we're collecting the right information. And what does that information mean? And then when we've got that historian, we've got that backup, we verify our results through all of the data that we get. Then that reinforces the data again. It's kind of how AI models work, really, if you think about it. You know? So, you know, we've got to do more work on that front. And you know, we've had a great week this week with just, you know, getting involved with not just motor circuit analysis, but motor current signature analysis as well when the machine's running. So these are two tests that we're doing right now. One obviously needs to be an isolated motor. We need to do unenergized. And motor current signature analysis is done when it's energized. Mark, just quickly, briefly explain to the viewers kind of like why we need to do both and why it's important that we don't miss one.
Okay. Doing de-energized testing, this tells you a lot more about the winding condition, contamination. You know, like we just pulled a motor apart in your workshop.
Yeah, we did. We did some tests.
Unfortunately, it's full of oil. The winding test or the contamination test, the dissipation factor, was elevated.
Because or was it insulated? You might not be able to tell without the contamination.
And the other one is that it's very, very good at picking up resistive imbalances.
Yes.
Now, I did some tests on the motor at the client, and we found a massive resistive imbalance. Like, it was
huge, wasn't it?
30-something%.
That's massive.
We've opened the lid on the motor, and there's an extension bar on one phase. So we've cleaned it all up and put it back together, and we retested back at the board, and that resistive imbalance is now down to, I think, 3.8%.
I mean, so just to clarify on that, 27% of that resistive imbalance was down to the fact we had dirty contacts.
And bad connections.
Bad connections as well.
Yeah.
So high resistance connections. And this is also why it's so important, because within the training Mark's done this week, and again, most companies don't do this either, it's just torque wrenching up your motor terminals.
Yep.
Because 3 of them, when we tried to take them off, we could barely take them off.
Oh, yeah.
They were so over-tightened.
Yeah, I mean, the
over-tightness can be bad as well in this.
It stretches a thread.
Yeah.
So the motor current, the motor circuit analysis is very good at picking up those types of problems.
Resistive imbalances
now
and problems.
the online testing with the motor current signature analysis, it's an equivalent of doing a VA on a motor, obviously while it's running, by taking high resolution current. And you can pick up things like air gap problems, rotor issues, but not only just those electrical issues, but also the bearings, gearbox, fans, pumps, whatever.
Just give you an example where this use case could be really valuable, and this is what we're going to add to our strategy as well. We do a lot of engines and alternators and generators. Obviously, depending on what engine is driving that, they're very noisy. And within vibration, it's always been a bit of a struggle. We can use filtering, and we've done it successfully, but it's a challenge, to be able to do what you need. You need to know what you're doing and what you're looking at. And as well, you need to have some really good mechanical transmission paths to the bearing, because if you don't put that sensor in the right particular place, you're going to pick up, harmonic indices from other areas from other sources, which is quite common for that signal to transfer. So what we can do with motor current signature analysis is clean the signal, right?
Yeah.
And we can use the electrical signal to understand the bearing defects as well, which can be more effective.
Inherently, you don't clean the signal, but you inherently get a cleaner spectra.
Yeah.
You don't tend to get these big humps of resonance issues.
The noise floors start to reduce massively.
Yeah. So it's very similar to VA, but with some nice changes.
We're using the motor current, and when we're using FFTs on the motor current, aren't we, over high sample rates, to be able to give us a very similar way of understanding spectral analysis with frequency, so we can pick out the certain faults. We're not just looking at a time wave, we're looking at certain frequencies, but it's very good for picking up rotor bar issues and electrical problems as well. Is really crystal clear for them. So
and the other side of that, it's extremely good at doing harmonic analysis.
Yes,
and
you showed me the harmonic stuff was really good. I love that.
And what we call supra harmonics. This is it takes harmonic analysis out to 22 kilohertz. So the beauty of that is it gives you at least 2 or 3, sometimes 4 times of orders of switching frequency. So when you do that analysis, you can tell if you've got a bearing current type issue from the inverter.
Wow, incredible.
And the latest version of it obviously has the alarm limits and the warning limits for those bearing currents. So it's extremely easy to do the analysis.
And that's the thing as well, the ease of use with it is very good. You only need to clamp onto one phase, and it's very innovative in the way that it actually outputs its results. Another really good use case for it is where VA is difficult in terms of access. We've got a customer with some submersible pumps, and we're able to use this technology to be able to, as we would just with vibration analysis, to check mechanically if the machine's okay, which would be really challenging for a vibration analysis scenario. So again, it doesn't replace our vibration analysis. We do 80% of our business models VA. We do lots of it. It's kind of how we've grown. But as we're growing, we're gradually adding these techniques to one another, especially on the critical assets. And it's given us so much more insight to be able to make better decision making. That's That's the thing we've got to do. Remember, anyone can analyse and monitor data long term, and a lot of the data models, if you're sampling at the right frequencies, are very similar. That's not where the value is with vibration analysis. The value is in the decision making of what you need to do.
Yep.
So
because you don't fix or improve reliability by detecting.
You don't. You need to use the data.
You've actually got to do some physical work.
Yeah, you can't just say, oh, well, it's going to break and do nothing. You have to take action, and that action needs to be informed, and it also needs to be in a reliability-centered way as well to be able to improve the process moving further down the line. And that's what we can also do out of this data. You know, if we understand it is shaft current and it is EDM, well, yeah, it's so important for us to be able to use that information and data and be able to actually, you know, make something of it and make it valuable, you know, moving forward. So, you know, I just got to say, Mark, just a huge shout out again to you this week. It's been absolute ball. I've had so much fun. I've learned so much. And, you know, we've now invested in the equipment and, you know, we're working together now, aren't we, to change reliability.
And it's a pleasure to come and work and... you just get such a good feeling when you impart some skills to different people, and especially electricians that are used to swinging so tight on motor terminations, and you go, wait, you just done it way too tight.
Calm down. But then that's the awareness as well that we all appreciate, because, you know, even all the electricians this week highly respect you now from that, and you can tell there's a level of respect there of, you know what, I can do my job a little bit better now, just by having a bit of awareness with some of the things that are not so obvious, and these little things as well. Now they're thinking a little bit differently, and that's culture change, and that's what we need to do in this industry. And it's very refreshing for us to see these customers, and that's what gives us enjoyment, right? That's what we do it for.
That's part of me. I'd much rather impart skills,
of course,
than it's what's got to happen in industry.
It is, and you know, we work. This relationship's only going to get bigger. We're already looking at other customers we can help together, and we need to do it together because, you know, it's a big task. It's a big task. There's so much to do. So, you know, we're now on our journey for it, and. Thanks, Mark, for coming this week. And there will be a part 3, because when he comes next time, what will we have? We'll have more data.
That's right. Yeah,
and this is what it's about, isn't it? As we start to build it, we'll have more data. So.
The next step is to integrate both mPower, the motor current signature analysis, and with the offline, and be able to do more AI analysis with the both technologies. Yes. That's going to be awesomely powerful.
This space, it's going to be powerful. So, guys, thank you so much for tuning in. Really appreciate your patience. We've not hit the podcast in a while because we've been so busy. But what one to come back with? The legend himself, Mark Gurney. So thank you, Mark.
Thanks very much.
Take care, guys. Have a great time.